So we're coming back to the unit circle a little bit, except now instead of just dealing with the unit circle itself, we're combining trig with it. As you know, the unit circle, it's a circle centered at the origin with a radius of 1, and we're going to be talking specifically about some point on the unit circle, xy. Well, an interesting consequence of the unit circle being 1 unit in radius is that that point xy is actually cos theta sine theta for this angle theta in at the origin. That's going to come into play a couple of times as we go through the section. Before we get into that, we need to talk about the other 3 trig functions, cosecant, secant, and cotangent. These 3 are just the reciprocals of sine, cosine, and tangent. So cosecant, reciprocal of sine, secant is reciprocal of cosine, and cotangent is reciprocal of tangent. Those again will come into play a couple of times, but let's look at example 1. We've got a point on the unit circle. It's the intersection of the unit circle and the terminal arm of theta. So the diagram to model the situation, I'll just skip to the next slide to do that. We would have our xy axis. Try to do that a little bit better. Our unit circle, and our point is going to be right about there, negative 3/5, negative 4/5. Terminal arm of theta, rotating there. So there's our diagram. Question B is asking us to find the values of the 6 trig functions, all of them. Well, as I said at the beginning, sine theta and cos theta are just the coordinates. Cos theta is the y-coordinate. Sine theta is the y-coordinate, so sine theta is negative 4/5. How do we know that? Because that point is on the unit circle. Cos theta is the x-coordinate, negative 3/5. I'm going to skip tangent just for a minute, and I'm going to move on to cosecant. Cosecant is the reciprocal of sine. So then cosecant would be negative 5/4. Secant is the reciprocal of cosine, so it'll be negative 5/3. Those will be by far the easiest that we have to deal with. Not that tangent and cotangent will be all that difficult, just a little bit more work. With tangent, the only information that we have is sine and cosine. The good news is there is actually an equation relating tangent with those two, and tangent equals sine over cosine. So now we can take and we can fill in. Sine is negative 4/5. Cosine is negative 3/5. And again, these should be exact values. They should be fractions, not decimals. So we have to deal with these as fractions. We're dividing two fractions. When we divide two fractions, first one stays the same. Second one flips and changes to a multiply. The old flip and multiply rule. If you take a look at this, we've got 5s that we can cancel right away. We've got negatives. 2 negatives, we'll make a positive here. And tangent of theta is 4/3. Now that we found tangent, cotangent becomes easy. Cotangent is the reciprocal of tangent. So cotangent is -3/4. That's all that there is to it. Finding the exact values of trig functions involves taking a look at those tables that we created in the last section. We created those tables in degrees, so A and B are a little bit off. We need to take those radians and convert them into degrees first. So in question A, we have 5 pi by 6. To convert that into degrees, multiply by 180 over pi. Pi's cancel. And we've got 150 degrees. So in A, what we're actually being asked to find is cosine of 150. Take a look back in the table that we developed yesterday. Cosine of 150 is -√3/2. B, same idea. We have radian measure of -4/3 pi. Multiply that by 180 over pi. Cancel pi's. Grand total of -240 degrees. This isn't in the table, however. But this is where we can use the concept of coterminal angles to help us get to an angle that is in the table. Remember that coterminal angles, you either add or subtract 360 degrees until you get to the angle that you want. Well, if we add 360 degrees, that takes us to 120 degrees, which does fit in the table. So what B is asking us to find is sine of 120 degrees. Look it up in the table. √3/2. The good news with C is that 315 degrees actually does show up in the table. The bad news is that secant doesn't. So in C, when I'm asking you to find secant of 315 degrees, we have to go back to the definition and know that secant is actually 1 over cosine. So what this question is actually asking you to find is cosine of 315 degrees. 1 over cosine 315, that is. Well, jump to the table, look up cosine 315, it's root 2 over 2. But again, we've got dividing with fractions. So, the top will stay the same, 1. The bottom will flip to become 2 over root 2. Nothing to cancel, nothing to simplify. So this becomes 2 over root 2. Now remember that we can't leave a root sign in the bottom. So to get rid of it and move it to the top, we need to multiply by root 2, top and bottom. Multiply it out, the top is going to become 2 root 2. The bottom, root 2 times root 2 is just 2. Twos can cancel. Final answer on C is going to be root 2. D complicates things even more. Cotangent of 270. Now not only do we have a function, the cotangent, that isn't in the table, we also have an angle that isn't in the table. Well, if we treat it the same as we treated C to begin with, cotangent of 270 would actually be 1 over tangent of 270. And here's the caveat. Because 270 is a multiple of 90 degrees, 270 is a quadrantal angle. So when we were dealing with the special triangles, we could not actually make a triangle out of a 270 degree angle because the hypotenuse would be on one of the other sides. So for quadrantal angles, we get to use a calculator. Don't type in the whole thing all at once, because quadrantal angles sometimes screw up the math, and especially with tangent. Just type in tangent of 270. When you do that, you'll get some kind of error message. Because it's not possible to take the tangent of 270. You now have to interpret what the calculator has told you. Calculator has told you error message. What that means is that tangent of 270 is infinite. Well, we can't leave something as 1 over infinity because infinity isn't actually a number, it's just a concept. What we do have to do is interpret what this means. We take 1 and we divide it by some incredibly large number. Well, if we take 1 and we divide it by 1, we would get 1. If we took 1 and divided it by 2, we'd get 0.5. 1 divided by 10, we'd get 0.1. 1 divided by 100 would be 0.01. 1 divided by 1,000 would be 0.001, and so on and so on and so on. So as the denominator gets bigger, 1 divided by a bigger number ends up being smaller. Eventually, the limit of this, what this division actually would end up being if we could divide by infinity, would be 0. And that's trig functions with the unit circle.